an example on curve sketching. The equation of a curve is given by y is equal to 2x cubed plus 3x squared. Find the x-intercept of the curve. Now, the x-intercept is the point where the graph, or rather the curve, touches the x-axis. Let's say that's the Cartesian plane, and let's say this is our curve. Now the point where it cuts the x-axis, that point it cuts the x-axis, this is what we refer to as the x-intercept. And at that point always the value of y is 0. So what we are going to do here, we are going to substitute 0. Yeah, we're going to substitute 0. Where we have y, we substitute 0, so that our equation becomes 0 is equal to 2x cubed plus 3x squared. Rearranging the terms, we have minus 2x cubed is equal to 3x squared is equal to 3x squared. Yeah, and then to get the value of x, you're going to do the manipulation, minus 2, then the value of x, divided by minus 2, divided by minus 2, the value of x is equal to negative 1.5. Now, for us to sketch a curve, we have to know where the curve is going to touch the x-axis and where the curve is going to touch the y-axis. Now let us go to the next bit, the y-intercept. This is the y-intercept of the curve. We want to get the y-intercept of the curve. This is the equation of the curve, or rather our function. The input is x is equal to 0, or rather the independent variable, the input. So we are going to substitute 0 everywhere, so that if x is 0, the y-intercept is equal to 0. Now we have already found the points where the curve cuts the x-intercept and the y-intercept respectively. Let us see what is required next. Determine the stationary points. Determine the stationary points. What is a stationary point? Determine a stationary point. We need to know what a stationary point is. So let me select my pen, and then I draw this. Let's say that is the Cartesian plane. Let me say that is the Cartesian plane. Now, a stationary point, though I have not defined it here, but I can just say it. A stationary point is a point where a curve, or rather a graph, turns around. We can call it a turning point if you like, or you can call it a minimum or a maximum. Now, you look at that point. This point here is what we call a turning point or a stationary point. Turning point or a stationary point. That point that is turning around, where the graph turns around, is what we call a stationary point. We need to know that even before we go to the solutions. I just want us to know that at any turning point, the gradient function is equal to 0, or we can say the rate of change, there is no rate of change at the stationary point, the rate of change is 0. Let us look at the solutions. Y is equal to 2x cubed plus 3x squared. That is the original equation. But what is the gradient function, or rather the derivative? dy dx is equal to, now let us see how the differentiation has happened. 3 drops here, you see 3. Let me use a pen. You see where 3 drops there, so that you multiply 3 times 2, and then you have to subtract 1, like you can see 3 minus 1, plus 2 also drops there, so that we can multiply with 3, and then you have to subtract 1 there, so that we have 2 times 3. Now you can do the multiplication. 3 times 2 is 6x squared. Why we saying x squared? X squared because 3 minus 1 is 2, plus 6x because 2 times 3 is 6. X squared, x to the power 2 minus 1 is x, so that's why 6x. And the gradient function of that particular curve is given by 6x squared plus 6x. But remember what I've just said, the gradient function of a stationary point, the gradient function at a point called stationary point is equal to 0. So we are going to equate this with a 0. We are going to equate that with 0, like we can see here. Can you see that equation there? So 0 is equal to 6x squared. Now the main idea here is to get the value of x. Now that we have already equated the gradient function with 0, it is now time that to get the value of x, because stationary point we are being asked for the coordinates, so we have to get the x coordinate first. So the x is -1. What is next? Like I have said, we need to get a coordinate. So what will help us get the coordinate is bringing back our original solution, our original function. We have said that is the original function, and then after that, this -1 here, substitute it in the original function, substitute the value of x to get the y coordinate. So we are going to come back to the original equation so that we substitute the value of x at the stationary point. Let us see what happens in the solution. So if x is equal to -1, okay, x is equal to -1, the x coordinate is -1. What about the y coordinate? Like I have said, we are going to use the original equation. Please don't confuse the original equation. I know you might be tempted to do the substitution with the gradient function, but it is wrong. You do the substitution with the original function, and then we just plug in the values of y there. The values of x, and then the x coordinate is 1. So this first stationary point, x is equal to this first stationary point, the coordinate is -1 and 1. So you have seen how we get the stationary point. But remember that this equation can also be factored out. How? We are talking about this gradient function can also be factored out. How? We can say, because it is equal to 0, 0 is equal to x, because x is common, and then we have 6x squared, 6x squared plus 6. Then we close the brackets. Now we can see that the value of x can also be equal to 0. The value of x can also be equal to 0. So in other words, this curve has got two stationary points. But let us inspect the equation. Let us inspect the equation. Let us try to inspect the equation and see the kind of equation it is. Let's go back. Because the highest power is 3, this one is a cubic equation. And in most cases, a cubic equation assumes this kind of a shape. It has got 2 turning points. So after having that rough idea, we can be able to know that this kind of an equation might have 2 stationary points. And one of it has already been found. What about the next? At x is equal to 0, automatically y will be equal to 0, because we have already established that the y-intercept is 0. So the second stationary point is 0, 0. And so let us now go to the next part of the problem. What is the problem asking? For each point in B1 above, determine whether it's a maximum or a minimum. Now, we need to note that we have 3 stationary points, types of stationary points. Number 1, we have a minima. Number 2, we have a maxima. Number 3, we have a point of inflection. Now let us see what kind of turning points these are. We start by writing the original equation and doing the substitution. Now, how are we going to do the substitution? Let me use a different color. Let me choose a different color. I have used red. More. Or let me use green now. Now, we want to see the nature of these stationary points, turning point. I have said it can be minima, maxima, or a point of inflection. So in this, for x, now we are going to guess a value that, focusing on x, we are going to maybe guess a value that is less than -1, and that is -2. Substitute it in the equation, the original equation, not the gradient function, and then you get -4. And you realize that in the left hand side, because when you draw the Cartesian plane, this is the left hand side, we have the negatives. We have the negative in the left hand side. And since we have the negatives in the left hand side, that tells you that, from this particular one, it tells you that the nature of that particular curve. Now it is curving how? If I substitute the value of x here, I will get -2 cubed is -8, -8 times 2, -16 plus that. You're going to get this. Okay. Now that means that the value of x is going downwards. It's going downwards. And this is the turning point. There is a turning point. Then when you go to the right hand side, okay, compare with the value of y, the right hand side of this, that is the positives, you realize that we say let the value of x be 0. Now this is the point, the right hand side, and then you say let the value of x be 0. Substitute 0.5, 0 is 0.5. Let me make that correction. 0.5. Substitute it here, and then you get 0.5. So it gives us a rough idea that it's sloping downwards in that direction, sloping downwards. So this becomes a maxima. It's maximum at that point. It is maximum. So let us look at the next stationary point. This next stationary point, we are also going to do the same substitution. The x is, we are going to say let x be minus 0.5, and then it will give us a 0.5. So we are going to see it's a decrease in nature because it is from minus 0.5 to 0, and this is flat. This is our turning point. And we're also going to do the next substitution in the right hand side. You're going to see there's an increase. There's an increase of y from 1 to 5. And therefore, the stationary point of coordinate 0, 0 is a minima. Now, after getting to know the x-intercept, the y-intercept, the points of stationary points, and to determine the nature of the stationary points, now we get to the juicy part, that is the sketching part, the sketching of this particular curve. The question asks, sketch the curve. Now that is our grid. Just know, not that it is not a must for you to use a grid or a scale. We are just sketching. I've decided to use a grid because for the purpose of illustration, and so that you can be able to understand. But if you're taught to sketch, it is not a must for you to use a grid. So we are going to mark the following. I want us to go back to Roman 1, part A, sketch and the curve sketching. What is our x-intercept? Our x-intercept is negative 1.5. Okay, so let us mark it in the graph. Negative 1.5. Here is the point. So I have marked that point. What is our x-intercept? That is y-intercept. Let me check once again. Let me be very sure of what I am doing. So x-intercept is 1.5. Yeah, negative 1.5. What is y-intercept? Y-intercept is 0. So let us mark the 0. Y-intercept is 0. Y-intercept is 0. Yeah. Now the next thing we are going to mark is the stationary point. The first stationary point is minus 1, 1. So let us look at minus 1, 1, where it is. Minus 1 and 1, here it is. Minus 1, 1. The next stationary point, let us try to see the next, is 0, 0. This one here, 0, 0 is the next stationary point. What are the nature of the turning points? This negative 1, 1 is a maxima, so that means that it is coming this way. So let us connect that. Let's connect that. So it is curving that way, and since 0, 0 is our minima, so it's gonna curve that way. It's gonna curve. Oh, where's my rubber? I want to do something here, but yes. Now, any particular graph must be labeled. So let us label our graph. Let us label. Let me use a different color. Let me use a different color. I think I really like red. Let me not be biased in this case. Our graph is, let us go to the equation. The equation, what's the equation? Y is equal to 2x cubed plus 3x squared. Y is equal to 2x cubed. So y is equal to 2 so y, we have to label the graph. Y is equal to 2x cubed plus 3x squared. So the graph has been labeled. So that is the graph.